Welcome to the 2 Degrees C Climate Chat podcast, your weekly guide to what's happening within the climate around the world. My name is Neil Vinnykerk, the Executive Director and a founding member of 2 Degrees C. Along with co-founders Dr. Carsten Schein and Jenny Dissen, we cover issues relating to the climate crisis. So join us as we explore in the 2 Degrees C Climate Chat. Welcome back to the second season of the 2 Degrees C Climate Chat podcast. Today we'll be talking to Dr. Thor Hanson, author, conservation biologist, a Guggenheim Fellow, a Switzer Environmental Fellow, and the 2013 winner of the John Burroughs Medal, given to the author of a book that the association has judged to be distinguished in the field of natural history. His book, Hurricane Lizards and Plastic Squid, explores the remarkable ways that plants and animals are responding to climate change, moving, adapting, and even evolving. So join us as we explore this book in the 2 Degrees C Climate Chat. Well, welcome to both of you, Dr. Carsten Schein and Dr. Hanson. Thanks for joining us today.
Hi, thanks.
Pleasure to be here.
So, Dr. Hanson, let's talk to you first. Congratulations on the book. Thank you so much for the copy. I really enjoyed reading it. It was fantastic.
I'm glad you enjoyed
Maybe you
it.
can introduce yourself to the listeners about your background and, what prompted you to write this specific book.
Sure. Well, my name is Thor Hanson. I'm an author and a biologist, and I became very interested over the years in academia in the number of stories and discoveries, really fascinating things that I was encountering that never seemed to make it beyond the audience of fellow scientists, beyond the peer-reviewed journals. And over time, I began to feel that I needed to be working in that space more and more. So, the last decade or so, I've begun writing more books for a popular audience, taking those really fascinating discoveries and ideas and trying to translate them into language and storytelling that anyone can enjoy. So, that has really become the major focus of my career of late. And I was very interested in doing a book about the biology of climate change, because among those many stories, one of the themes that has arisen, I think, for any biologist over the decades is how climate change is this overarching influence in systems around the world. And you head out to the field to study one thing and end up with a very different data set because conditions on the ground have changed so much. Yet in public discourse, in all manner of articles and discussions, we tend to summarize that whole aspect of climate change, the biological impacts and the response of species in nature, with one image, that iconic image of the polar bear stranded on the shrinking iceberg. And in doing so, too often the conversation stops there, and we overlook, as a community, this rich and vital backstory that really lies at the heart of all climate change scenarios. Because in a sense, it's not so much the change itself that matters as it is how plants and animals respond to that change. In that, if species all got along just as well in any condition, then tweaking the weather one way or another wouldn't matter in the slightest. But of course, that's not how nature works. The biodiversity of our planet is built upon eons and eons of specialization over time, with all of these species that are adapted to particular climatic conditions. So when those conditions change, species respond, and it's the sum of those responses that really will determine the future, theirs as well as our own. So that is, I guess, in a rather large nutshell, what brought me to write this book.
Oh, that's great. So, Carsten, you're a climatologist, and I wanted to ask you this question before we even started going through the concepts that are discussed in the book, and that's really like, how can changes how can biodiversity changes in a local area affect climate, if at all, and how does that unfold?
Yeah, it's a hugely critical issue because it does. The climate system is a big part of the climate system is the land cover and the land use, and the reflectivity of the surface, um, the amount of carbon being sequestered biological factors in those areas, and So every change on the Earth's surface is going to have some effect at a microclimate scale, at a local climate scale, and those changes then can factor up into regional and even global scales. We think back to Lorenz's chaos theories, for example, and how a butterfly flapping its wings in the Amazon can create a hurricane that destroys Miami or something along those lines. Um,
Yes.
but at a much smaller scale, if we think about, for example, forest clearing in the Amazon, um, a small area that's cleared away, that changes the water balance in that area. That changes um, the amount of evapotranspiration that might be available for a thunderstorm, uh, which then in turn changes slightly the local circulations, and just it spirals. It can potentially spiral out of control from there. And of course, the more of that land gets cleared, the bigger the effect becomes. And so that, I think, goes for any habitat change that we might see, um, in any part of the world.
All right. Well, let's look at some of these concepts, Tor, and I appreciate you taking some time out of your day to help us understand them, because there are quite a few broad concepts in here that are quite interesting, actually. Um, let's talk about in the beginning of the book, you speak a bit about tropicalization. And there's a story about the Syncnopodia starfish, the sunflower starfish. Maybe you can help us understand a bit about tropicalization.
Sure. So tropicalization is a sort of climate biology lingo buzzword for this very common theme of species moving towards the poles, in that if the climate changes and you have the ability to move, chances are you're going to do it. Fanning out across oceans or fanning out across landscapes, looking for the climatic conditions that you're used to. And we see this happening in species everywhere. As things warm, species moving north in the northern hemisphere or moving south in the southern hemisphere. The estimates are that between 25 and 85% of all species on the planet are shifting their ranges now in response to climate change, which, even at the low end of that estimate, is 1 out of 4 species. So it is a massive, massive perturbation in our environment. Not only that, but what perhaps makes it even more interesting is that species are not moving in lockstep. It's not as if whole communities are moving together in one direction or another. Species respond differently. And so, in doing so, they are creating, when they stop moving and when they arrive at new locations, they are creating novel ecosystems, in a sense, upending all of these vital ecological relationships that lie at the heart of any ecosystem. Things like competition and predation, things like pollination, all of these relationships that tie species together really get disturbed when you start mixing new species together. And we're doing that at a massive, massive scale. And one of the things then that can also change as we see things shifting in these great spans of latitude is disease prevalence. And you mentioned the starfish example, which is a really interesting example in that we're still not quite sure precisely what has caused this die-off of sunflower stars and sea stars and other starfish species in the northeastern part of the Pacific, all along the west coast of North America. But it seems to be a disease. And the really fascinating part of this study, in my opinion, it was sort of an inadvertent experiment that occurred at a research laboratory where they were trying to discover what it was that was harming these starfish. And it's a terrible disease, I should mention. This is a wasting disease that causes the legs of starfish to detach. It causes the bodies to deteriorate almost in real time. These things just absolutely ooze, if you will, and perish. So it's a terrible disease. And they had a tank full of healthy starfish, which you need if you're going to be trying to understand what's going on. You have to have healthy ones to compare. And so they had the healthy starfish. And then the cleaning crew at the lab came through, cleaning out tanks and so on and so forth. And they shut off the water to the tank while they were cleaning it. And then they forgot to turn the flow of cold water back on into the tank. And part of the tank was in the sunlight. And in a very short period of time, the temperature went up in that tank. Not too long, but long enough so that the temperature got pretty warm. And then someone noticed, oh my gosh, and they turned the water back on again. And, luckily it looked like the starfish were fine. It didn't get too hot and so on. And a day later or 2 days later, they came back in to continue this project, and they looked, and all the starfish in that tank suddenly were infected with this disease, demonstrating that, in fact, they had been carrying the disease, and what triggered the symptoms to express in their bodies was heat stress. Right. So bringing together a number of threads here, if indeed you have different diseases distributed differently, moving north, if you will, we see it with things we're more familiar with too, like malaria and so forth. These things moving north, but also combined with the stress of increased temperatures, in this case, water temperatures, surface water temperatures, which are going up in the vast majority of places in the ocean. You see this perfect storm that can then cause real damage to species and to the ecosystems in which they persist.
Right, and I know, Carson, there's a new report on ocean heat out right now, I think.
Yeah, that's right. It was just recently announced that this past year the ocean temperatures have reached their record warmest since observations began. So that's a pretty important finding that is going to have some significant ramifications for the ocean life.
Yeah, and a significant die-off in the Pacific Northwest in 2021 as well.
Correct, yeah.
Described Barefoot Luxury, the casually sophisticated Southern Cross Club is Little Cayman's original resort. This hidden gem is as unique and vibrant as the island it inhabits. A true island treasure, it is the perfect place to dive, fish, and relax. Its 14 beachfront bungalows are situated on 900 feet of white sand, only minutes from the world-class diving found only in Little Cayman. Visit www.southerncrossclub.com to book your escape to tranquility. Well, let's move on to another concept that I wanted to look at. And this was the concept of upslope migration. And you had another great example there with regard to the mountain pine beetles. Maybe you can tell us a bit about that.
This is another example of this, movement and translocation of species and the implications that it can have. So we have things moving north or south toward the poles, but that also translates ecologically into movements in altitude, movements in elevation, and that you can go north in the northern hemisphere and it cools off, or you can also go uphill in mountains. And the pine beetles are doing both. So they're surging north into habitats that were once inhospitable to them because they got too cold in the wintertime. But those winter temperatures are no longer reaching lethal temperature for pine beetles. So the pine beetles have surged north over the past several decades into what we call naive forests, forests full of particularly lodgepole pine, but other species, other conifers too, that the pine beetles can attack, that have little or no experience defending against this particular species. And so the pine beetles arrive and they find a defenseless forest full of food, and they surge through, and there's a mass die-off of trees happening, surging north, but also then up and over the Rocky Mountains, which had also been a barrier to them, particularly up into Canada. And so now you see these pine beetles surging in two directions, north and now also east, moving across into naive forests, and they're expected to reach all the way across and hit the eastern seaboard in the years ahead, because there's very little that is going to stop them at this stage.
Right. And that actually brings us to the next topic. And actually, the reason that this book of yours caught my eye, because there's a concept of the escalator to extinction. And, speaking of upslope and going in vertical profiles, maybe you can explain that.
This is another really interesting example. One of the worries that we have in climate change biology is what happens to the species at the top. If you are seeing this movement in elevation of species ascending mountains, well, okay, that's actually not a bad outcome for those species. If they can move uphill and survive, that's a good climate change outcome. But what about the species that were already there, particularly when you get to the top? Will they be driven off? Will their habitat simply disappear?
Hmm.
This has been a worry for a long time, but wasn't put into practice or wasn't observed until quite recently with some studies down on tropical mountains where there happened to be really good data sets from 30, 40 years ago that could be repeated. And so there have been a number of them now. Some of the more well-known ones have been done on bird communities.
Hmm.
So situations where some ornithologists, including Jared Diamond, a very noted ornithologist and environmental historian now, author of a number of books. In his early career, he did a study down in Southeast Asia where he went up mountain slopes and studied the differences in bird communities across elevational gradients. So a young fellow just doing his doctoral work got a hold of those old data sets and went and repeated those studies.
Hmm.
Ben Freeman. And he went out with his wife as a collaborator. They did this marvelous reenactment of those old transects up these mountains and found and could show with the data that in fact species were moving. Whole communities of birds were moving uphill in response to temperature because these places had not changed otherwise. The forests themselves were undisturbed, similar condition. So the big change had been in temperature readings.
Hmm.
And so they saw that happening. And then he wanted to find another place to study this, another old data set that he could repeat that might get at this question of what's happening at the top. And he found the perfect data set down in the Amazon, on a ridge top there that had been, again, studied decades previously, and was able to show that birds that had been common living at the top of this high mountain ridge had simply disappeared in the new data set. They were just gone. Common birds had disappeared and so forth. And so those birds still existed on higher mountains in the area, but it showed this risk that is now prevalent in mountain systems across the globe, really, that the species that are living at the top may be nudged out, driven extinct by this escalator, if you will, of species moving up from below. So it is sort of seeing theory put into practice through this research on birds, but now it's been replicated on some insects and other groups as well.
And right, and that's because of the food web that interlinks the species. So the prey that the birds are eating could be related to a vegetation, could be related to
Yes.
altitude and humidity.
Again, you see these changes that, much like what we were talking about with latitudinal changes, where you're creating novel communities, because not
Hmm.
all the species are moving. Some are moving. Some are moving really far. Some are moving fast. There are some that are even moving downslope. It's not it's not uniform. And so
Yeah.
what happens is all of those ecological relationships are up in the air,
Hmm.
and the species that disappear are the ones that are most vulnerable to those changes.
Right.
And I think that really highlights the need to have much more reliable temperature information in these landscapes that we really don't have right now. You know, the wildlands and such, there are very few weather observations out there because people don't live there. So having observations can really be important for understanding how these habitats may be shifting
Right.
and where they may be shifting.
Absolutely. Yeah, and I also would say that the the smaller scale from which you can have that kind of data, the better, because there are these nuances in habitat that in some cases can provide refuge to species. We can see this in data in various situations. Some things that are pretty intuitive. If you have a deep canyon that remains shady, it's going to be cooler than the surrounding landscape and so forth. But even at a small scale, there is some data coming out now that shows that these small differences in temperature can make a huge impact on the species that can live there. And there is some hope that some species will be using these micro refugia, if you will, in a whole range of situations. But you need data. You need some temperature readings to track
And
those things.
and from work I've done, some of these species are, a tenth of a degree is all they can tolerate and change, and then they start to stress tremendously.
Hmm.
Yeah.
And these responses in your book, you've segregated the responses into moving, adapting, evolving, and then taking refuge, like you said.
Mm-hmm.
And there's some interesting examples in all of those. And the first I think we can talk about is this concept of plasticity. Maybe you can define that.
Sure. Well, I think for some of us, at least, comic book fans may remember a comic book character called Plastic Man who could stretch his body into any shape and defeat, criminals with these very creative body shapes that he would take on and so forth. So I think we all wish in biology that every species out there was like Plastic Man at this point, able to adapt quickly and change in the face of this rapid environmental change. But the concept plasticity is what biologists refer to as the innate ability of a species to respond to change, in a sense. It's already built into the genome of a species.
Mm-hmm.
And it can play out in a number of ways. There is behavioral plasticity. For example, we had what we called the heat dome here in the Pacific Northwest, where I live this past summer, where temperatures were far, far outside of normal, over 100 degrees, even 115 or more in places. And there were a number of instances where black bears were taking refuge, if you will. They were cooling off in backyard swimming pools. And this, popped up in a number of places. People were amazed to see these bears in their backyards cooling off. Well, that's great behavioral plasticity. Bears have, they could just do that. They didn't have to evolve to come up with that scenario. They just knew that that was a cool place to cool down.
Mm-hmm.
But plasticity can also be not just behavioral change or changes in diet that are rapid. It can also be physiological changes. Sometimes, for some species, in the very earliest stages of life, there is a trigger that can determine the course of their body type, if you will, in the future, and do what we call in biology triggering a different phenotype from the same genotype, if you will. Genes being what regulates the way the body will grow and express and so forth, and the phenotypes being the results of that. Well, it turns out that that can take different paths for some of these very plastic species. And one of the grand champions of that is one featured even in the title of the book, the plastic squid. This is the Humboldt squid that simply disappeared from fishing grounds, traditional fishing grounds in the Gulf of Mexico. No one was catching these things any longer, and the assumption was that they had moved. It's a species that can move, and so everyone assumed they had gone to cooler waters after this series of marine heat waves came through that region. Until they went out and measured and looked and surveyed for the Humboldt squid and found that in fact they were still there in similar or even greater numbers in some cases than before. But their whole life strategy had changed in response to that heat stress. It had triggered this different phenotype from their genotype in that they lived half as long, they matured twice as fast. They, yes, had behavioral plasticity too. They were eating different foods. But under those conditions, their body type was drastically different, a fraction of its former size. Where you used to have these squid reaching 5-6 feet in length, you had them now mature adults at less than a foot in some cases, or less than 2 feet. I mean, they were small squid, so small that they could not bite upon the hooks that had formerly been used to catch them. And the very few that fishers were catching in that area, they were throwing back, assuming they were juveniles or maybe another species. It had completely changed its life strategy and its physiology in response to that heat stress. And that was all built in to the genome of the species. So that kind of plastic response, that's an extreme case, but it's something that will give certain species, those that have it, a real advantage in this period of rapid change.
Mm-hmm. And then, in addition to that, also the name of the book, the hurricane lizards. You had a very interesting example there, but that speaks more to the evolution of the species. But or am I wrong?
It does. No, you're absolutely right. Most of what we're measuring now in terms of responses are some version of plasticity, changes in behavior, changes in diet, change in various strategies and relationships, or even these physiological changes that we're starting to measure as well. But there are these tantalizing signs now in some data sets where we see signs of evolution in response to climate change happening quite rapidly, really in real time. And a great example of that is the hurricane lizard example, which comes to us from the Turks and Caicos Islands in the Caribbean, where a fellow named Colin Donahue had gone out to survey this species of anole lizards, which is a small, sort of distant cousin to the iguana, if you can imagine that shape on a small scale. This is an anole, and there is a Turks and Caicos anole that lives in that archipelago. And he had gone out to survey those lizards, take all these measurements, because they were going to try to remove Norway rats from 2 of the islands. Mm-hmm. The rats had been having all sorts of impacts on the native ecosystem, including preying upon these lizards. And so the idea was you measure the lizards and various other things, get rid of the rats, and then see how the native system responds. So he went out and did all of that field work, he and his team. And then 2 weeks after they left, 2 hurricanes struck the islands back to back. Category 4, Category 5 hurricanes, winds reaching 175 miles per hour, upending trees and collapsing buildings, a catastrophe for the human and natural populations of the islands. And so, of course, the rat project was put on an indefinite hold. But Colin realized that he then had the opportunity, if he could get the funding together and get back down there, to study the potential effects of those hurricanes on this lizard population. Mm-hmm. So he did that, went back and sort of experienced what must have felt like scientific deja vu, and that he repeated the precise field experiment he had just done 6 weeks earlier. They went through the whole thing again, captured lizards, measured them in the same ways, and we're looking to answer the question, is the post-hurricane population measurably different than the pre-hurricane population? And in fact, it was. They immediately noticed in the data that the surviving lizards were the ones with the largest toe pads and strong front legs and short back legs, which was a bit of a mystery to him. He could understand that large toe pads, which are sticky and give you more traction, might help a creature hang on in heavy winds. But why the short back legs? So luckily, Colin is extremely creative as a scientist, and he had planned ahead and brought with him in his luggage a leaf blower from the States. And he told me it was quite a comical experience to try to explain to the customs officials why he was traveling with landscaping equipment for science. But he got it through, and he had it there and used it to answer this question. What do the lizards do in hurricane force winds? You can't bloody well stand out there during a hurricane taking notes. So they recreated a hurricane using the leaf blower right there back at the hotel. And I have always wondered what, the people in the next room must have been thinking when, this leaf blower was going next door all day long. But at any rate, they did this and were able to demonstrate the behavior of the lizards in a hurricane. And of course, they go to the lee side of a stick and they hold on tight. But as the wind increases in speed, the back legs of the lizards would slip, and until the whole body really then was flapping like a banner in the wind, holding on for dear life with those strong front legs and the big toe pads. And the short back legs reduced the drag on the body. So the ones with the shorter legs could hang on longer than long-legged lizards, and they were the ones that survived. So he realized when he saw that it perfectly explained his data and that he'd managed to capture this natural selection, essentially, survival of the fittest, playing out not over thousands of years, but really over the course of a single field season. And then in going back to the same locations later, seeing how those traits had been passed on to the next generation, and then looking at, asking some other questions sort of at a broader geographical scale, really showed that this was directional selection driven by increased power or increased frequency of powerful hurricanes, changing the physiology of these lizards, changing their bodies really as an adaptation, evolutionary adaptation to climate change.
Yeah, that's fantastic, and it was great to read in the book as well, and certainly the pictures helped. But but one of the strategies that we touched on with migration is move, but there's also you mentioned it before, this concept of refugia. Maybe you can recount the story of the pika there.
Oh, yeah, it's a very interesting story. I mean, when we think about climate change, there are certain sort of, emblematic species that seem at particular risk, polar bears, or, species in rapidly changing environments like these mountaintop alpine sorts of species. And one of those is this little fuzzy ball of a creature related to rabbits called the pika or pika. And this is a species that lives mostly at higher elevations and was thought to be one that was threatened. As those habitats warmed, it would have no place to live and would be lost in that sort of escalator process we were also talking about. But a wonderful scientist named Connie Millar went out with a crew to sort of study this, see what was actually happening in the field. Where were these pika populations and how was that changing? Were they winking out, and disappearing? And some were, but they also found a number of populations persisting at lower elevations. Quite low, sometimes in situations where they weren't surrounded by alpine vegetation, they were surrounded by sagebrush and all these really warm habitats. And how were these creatures hanging on? And it has to do with their habitat and their lifestyle, in that pikas live in talus slopes, which are big jumbles of rock that have eroded off of a cliff or a mountainside and formed this pile, this descending pile of rocks that has a lot of space in between all those boulders. And the pikas live in there. They den in those little interstitial spaces between the boulders and so on. And then they come out usually around the bottom where there's a little meadow, and they feed upon the grasses and the wildflowers, and they nip those things off and they take them back up into the talus slope, and they build what even in scientific papers are called haystacks. These little piles of dried vegetation they stuff in there, and then they feed upon those during the cold part of the year when there's nothing to eat out in the meadows, right? So this is the life strategy. And what Connie's crew realized was that something was going on in terms of the microclimate in those talus slopes. And they started measuring temperatures and realized that the temperature in those shady spaces beneath the rocks was dramatically cooler than everything surrounding it. Mm-hmm. Allowing the pikas to hang on in these habitats where they would never make a living otherwise. You had, 5, 6, 7 degrees difference Fahrenheit between the temperatures just a few meters away in the surrounding habitat. And so this then turns out to be a good example of this idea of taking refuge, that if you're lucky enough to have some sort of habitat refuge in your neighborhood as a species, whether you're a pika or whether you're a plant or other creature, whatever it is that you have in the neighborhood that allows you to maintain your comfort zone, you can persist a lot longer in an environment that is warming rapidly. And so this was a great example of how taking the time to get out into the field and seeing what's happening can tweak what we expect in terms of our theories and lead to some very, surprising consequences, sometimes negative, sometimes positive, in this case for the pika, rather than a poster child for, rapid extinction from climate change. They may become now a poster child of a way to buy yourself a lot of time.
Right, and that a clear demonstration of the absolute need for that hyper local climate data, Carsten.
Yeah, absolutely. Just the ability to identify where those tolerable temperatures are occurring, and how those geographies are shifting through time is absolutely critical to maybe building models to try to understand how much time that the pika has at that particular elevation, or where it may have to move if movement is necessary.
Mm-hmm. And that species, I still believe, is on the IUCN critically endangered species list. By stand to correction, but I believe it is.
Yeah. Yeah. There are a number of species, all of them at risk at one level or another. So this was for people who study the pika, this is a welcome bit of potentially good news.
Yeah, for sure.
And
Now,
that's something that we're trying to do with our 2°C is get people who are out there in nature hiking in the Rockies and such, or through these habitats, to carry a temperature sensor
Yeah.
to share those data with scientists so that they can have better understanding of what's going on out there
yeah,
environmentally.
this podcast series is essentially in support of our efforts to do that. It's really just a voice so that we can get people
That's
to
what we're doing.
understand what we're doing. But
Yeah. I think it's terrific.
yeah. We're not trying to replace science in any way, shape, or form. We're really trying to take that low decimal place value of 1 in a simple, low-cost instrument and offer it to everyone, to offer them the opportunity to participate, so we can add to the climate record to see where highlight where problems could exist.
Yep.
Yeah. Well, and the book I'm working on right now is very much about backyard biology and citizen science, and how anyone can participate in
Mm-hmm.
creating these incredible data sets and allow scientists to ask questions they couldn't possibly have asked before these things were
Yeah.
possible. So, I mean, what you're doing is very much in line with that. I think it's
And
great.
that's just the thing, is that a lot of the hesitancy with citizen science has always been in the scientific uptake of the data, because in many cases they don't trust it.
Yeah.
It's too qualitative, things like that. But so our ideas here, just let's take the observer bias out of the equation. You clip
Right.
this thing on your backpack while you're walking, and it's doing the work.
I know. And yeah, so it's a brilliant idea.
With so many wonderful destinations around the world to choose from, a little help can go a long way. Quest Dive Adventures is your premium adventure travel company, offering a wide and diverse selection of destinations to choose from. With dive adventures from the Pacific to the Caribbean, and adventure travel from Costa Rica to Africa. Quest Dive Adventures offers packages including flights and accommodations, activities, transfers, diving, and more. Everything to enjoy your perfect vacation. What's your quest? Some very interesting bird topics actually in the book came out, and I know that one of them has to do with resilience, not specifically with the Audubon, but with resilience with regard to the dove keys.
Yeah, the dove key example is another fascinating study and a great example of what we just were touching upon, that you get out into the field and you find these surprises.
Mm-hmm.
And again, this is a species that if you had sat down, before this study or any time over the last few decades, and with a bunch of climate change biologists and started making lists of species that were at risk, that were going to be the first climate change casualties, dovekey would have appeared on a lot of those lists, because here you have this little seabird that feeds along the edge of the pack ice. So you can imagine that picture we know so well of the polar bear on the iceberg. Well, if you could scoot the polar bear out of the way and peer over the edge of the ice, you might catch a glimpse of the dovekies. They would be right there. Mm-hmm. Because that particular habitat where the edge of the ice meets the Arctic Ocean there is rich in the plankton upon which they feed, which is a wonderful strategy for dovekies, except when the ice begins to retreat, as it is now rapidly, farther and farther from the islands where the dovekies gather to breed, they're in a bit of a bind because they have farther and farther to fly to gather food to bring back to feed to their chicks. And so you can imagine that it's a very linear relationship, and the predictions were when that ice got too far away, they wouldn't be able to get enough food back in time to feed the chicks. Starvation of chicks, population crash, end of story. So a French scientist named David Gremillet and some collaborators participated several years ago in this big effort to study climate change impacts in the Russian Arctic, a place called Franz Josef Land, which is an archipelago up there in the high Arctic. And there were all sorts of people doing all sorts of things. But his team was dropped off at this old Soviet research station where there was a dovekey colony where they could take some measurements and do some studies. And he told me that, yes, we expected certain things. We had calculated how far the ice was, and we knew that the dovekies were going to have to fly at least an hour to reach it. And they had these little transmitters that they put on several of the birds. And then he said it was the most exciting moment of his research career when they got the first data back, and they're sitting around in the research station in the evening with their laptops and all of their Russian counterparts. And, bingo, they hit the button and learn that the dovekies have been in the air for 4 minutes. So, everyone's looking at what is going on. I mean, obviously something had changed, something unexpected had happened. The dovekies had pivoted from their traditional food source to something else right there in the neighborhood. But what was it? And, so they sit around and they come up with a new theory, over the course of the evening, which I imagine in my mind anyway, involved a few sips of the local vodka. But they realized that there was a potential food source for the dovekies being created in this new environment, right at the mouth of the fjord, in that the blue glacial meltwater from the island glaciers, which are now retreating and melting quickly, would slam into the dark waters of the Arctic Ocean right there and they could see it. They could see this line of blue hitting the dark water. And David and one of his colleagues, had trained as oceanographers before they even got interested in birds, and they knew that sort of an interface between two very different water types would create a curtain of plankton that had been stunned or even killed by the transition. For those tiny creatures swimming from one type of water that's so different into another, it's like driving into a brick wall. And so for the creatures that feed upon that plankton, like the dovekies, that created a bonanza of food. And in fact, when they finally got out there to study what was going on it's a great adventure. They have this rickety old deflated dinghy is the only thing they had, but they got out there to that transition zone and saw that the dovekies were all there feeding, plucking the stunned or dead plankton right off of that underwater curtain where those two bits of or two different sort of water types met. And so immediately then their research project changed, not from a study of decline, but a study then of resilience, in that the glaciers at the rate upon which they're melting, will create and have created this new food source for dovekies that should last for potentially 180 years. But at least 100. So it's suddenly the dovekies have bought themselves an extra century. And it's not a permanent solution, because if the climate continues to warm as it is, those glaciers will eventually be gone and that food source will disappear. But it does buy them a lot of time to hopefully find new adaptations to this rapid change in their environment.
Mm. Yeah, it is a fantastic story of resilience, and also an important message of hope, that there may indeed still be other opportunities for hope. But it does, in converse, offer some reflection to some other species, like you mentioned in the book, like the Joshua tree. Something important, especially to the United States, where we're all living. Maybe you can recount that species' plight.
So the plight of the Joshua tree brings together a whole bunch of threads in climate change biology, stretching back a surprising amount of time. And this project is it's really an interesting scientific story because the fellow who did this work was never able to get it funded, so they did it on the cheap in a sense. But he was an expert on the paleoflora of the desert Southwest in the United States, and he knew where Joshua trees had lived in the past because he studied the middens of pack rats, which gather vegetation from their immediate surroundings, make these huge middens, and then they pee all over them. And over time, that pee hardens into something that's like amber. It just seals in those plant remains, and they're good for tens of thousands of years. So he studied pack rat middens, and he knew that Joshua trees were in all these places where they disappeared from. He could see how in previous examples of temperature fluctuation that Joshua trees had moved across the landscape in a sense. And yet they're not moving now. He could go out into modern groves of Joshua trees and find that there were uh, young trees only a few meters from the parents and nothing being distributed or dispersed farther. Nothing that could possibly allow Joshua trees to keep up with this rapid change happening in their environment now. In fact, the national park in the States, Joshua Tree National Park, is very much at risk of not having any Joshua trees in the very near future.
Mm.
And so this led him to start thinking about what else had changed since the last time that Joshua trees had to shift their range in response to a difference in temperature. And luckily, he had been a student of a fellow named Martin years ago, and they'd gone to the Grand Canyon and into a cave there that was filled with ground sloth dung from this Shasta giant ground sloth, a creature that had gone extinct 14,000 years ago, was suspected to be part of this his professor's major theory, which was the Pleistocene overkill hypothesis, that Pleistocene hunters, human hunters, had slaughtered all of these large animals and led to a massive die-off of larger creatures in that time, from mastodons to giant ground sloths and so forth. And anyhow, and he had noticed at that time that the dung of the Shasta giant ground sloth, like the dung and like the middens of the pack rats, was full of Joshua tree remains. And he realized that here was what was missing. The long distance seed disperser of the Joshua tree had gone extinct since the last major climate episode. And with that piece of its ecology gone, there was little hope for it to keep pace with modern climate change. Mm-hmm. So what I really enjoy about this story is that it brings together not only the complexity of these relationships and the importance of what happens when you disturb the ecology, in this case, this relationship between a couple of species, but it reminds us as well that modern climate change is impacting plants and animals that are already stressed and impacted by the many other changes that we have made to their environment. Right. Habitat loss, pollution, what have you, including potentially these impacts from 14,000 years ago, in this case, when hunter-gatherers are likely to have played a role in the extinction of the seed disperser for the Joshua tree.
Right. Yeah, a very interesting story. I did enjoy making that association. I do want to discuss a couple of other things as we look backwards in time towards that time of the giant sloth. you do also make reference to other mechanisms and tools that we have at our hands now to look back in time at the climate record. And specifically, you mentioned we've got the fossil record, we've got leaf biology, and we've got ice cores. Ice cores we're familiar with, but leaf biology was interesting to me. There was some interesting stories in the book that really raised an eyebrow because I'd not thought about those before.
Yeah, it's one of these funny observations that has been made in science, in this case by botanists over time, looking at leaf shape, just the shapes of leaves in relation to the temperatures where they grow, and the very incontrovertible fact that you have more complex leaf shapes in warmer sort of tropical environments than you do when you get up to cooler environments where the leaf shapes tend to be more simple. Just one of those things that people, and there's a law about this. Oh yeah, we know that's the case. But it really has taken on new meaning for people studying climate change events from long ago, in that when you have plant remains in the fossil record, the proportion and the complexity of leaf shapes turns out to be a really good marker for temperature over long periods of time. And so you can track the temperature changes, even if you don't know the species of the plants you're looking at, simply by looking at a plant community and doing a little bit of math on the proportion of and the depths of the lobes of the leaves and all these sorts of things. This leaf analysis turns out to be a great proxy for temperature studies in the distant past.
Yeah, it seems to me, Carson, I think that many people have been studying climate without even knowing it for a really long time, even if they were merely studying leaves. So that was an interesting fact in the book.
Sure, and it's always wonderful when those connections get made. Really
Yeah.
I have one last concept that I want to discuss, which is really pertinent right now, and it's bringing to conclusion in the book, and that's really climate driving conflict. You had some interesting thoughts about that.
Sure. If you look at, one of the questions where it all boils, or where the rubber meets the road, so to speak, for many people is, well, what does this mean for human societies to go through a period of change as we're experiencing now? And, there are many examples of this from the historical record and smaller swings of climate that have led to social changes of one form or another, or have been associated with periods of rapid change socially as well. And people look to the Little Ice Age as one example. And, this century of cooler than normal temperatures in Europe particularly, and that, coincidentally was also a period of great political strife and conflict. Very few years passed during the Little Ice Age where there weren't major wars being fought in Europe.
And this is not a long time ago.
No, yes, yeah, good point. Yeah, this is 15th century, 16th century. This it's within the historical record. There's plenty of factual data to base all of this upon. We don't have to. We could look at leaf shape, but we don't need leaf shape to study this stuff. We know what was happening in terms of temperature.
And
we know
art.
what was happening in terms of art. You see it in these wintry scenes, and you see it in artistic depictions of these ice fairs that would occur on the Thames River in London or in places throughout Europe where the ice was so thick that people would have fairs in the winter with games, and they would have ice races with wind-driven sleds, and they would have bear baiting and food courts, and I mean it's like a mall and a circus all wrapped up into one, and they'd go on for weeks and months because it was so bloody cold and the ice was so thick you could do anything on it. So that period of time then was closely associated with a lot of social and political strife. And there are a number then, if you start to really get into this niche in conflict research and climate research and where they overlap, there are all of these very interesting examples of temperature associations with human aggression, if you will. You can measure these things in interesting ways. There are studies from the history in China. There are studies from the Central America in more recent times, where you very closely see these correlations between temperature and degrees of conflict. And you certainly see it in this very well documented example of the Little Ice Age and the amount of strife that was occurring during that period. So it's one of the connections that should give us all pause, as members of our society, looking out and seeing that, in fact, we're in a period of rapid warming, and we're in a period that there is a lot where there's a lot of strife as well. You see a lot of movement of people as well as animals. You see a lot of political strife and conflict around the globe. Not that climate change is the cause, but it is what this is a great term that military strategists use, what they refer to as a threat multiplier. Mm-hmm. So if you have some threat in the environment, if you're a military strategist and you know that whether it's food shortages or political instability or what have you, or migration, that are threats to the stability of a particular society, climate change multiplies the threat. So I think that threat multiplier concept that military strategists use is actually quite broadly applicable in social contexts and also in biology in terms of how we look at climate change. Even for the things that it is not triggering directly, it may be multiplying the threats that are already there.
Yeah, it seems to me that human migration is inextricably linked to climate.
Yeah. There's a really interesting, very small but telling example, I think, from the recent past here, which reminds us that, we're coping with this crisis, drawing on the very same toolbox as any other species on the planet. And that is the recent hurricane that struck New Orleans. And it was bearing down upon the city, and everyone had pegged their hopes on the new seawall that had been created around New Orleans since Hurricane Katrina in 2004. And here comes another big storm, massive storm coming straight toward the city. Will the seawall hold? And in fact, it did. So you see there an example of adaptation, if you will, in place. The people were still there. They built a seawall. It held back this climate-driven storm. However, that seawall protected a population in the urban part of New Orleans that is still 20% smaller than it was in 2004 before Hurricane Katrina. Because in the interim, tens of thousands of people made the decision that place was no longer habitable to them. They moved and they didn't come back. They left. So you see in that one example how we are responding very much like other creatures on the planet, trying to adapt in place, or in some cases, moving to the places where we can remain comfortable.
Right. In closing, there were two things that your book gave me. Number one, and I'm reading from my notes, and we can come back to this one. It is the topic of everything we can. I'd like to maybe close with that. But before that, there was an interesting concept there of stronger policies and strong leadership carry forward climate agendas, but they will be the results of cultural change, not because of it. I wrote that down because I thought that was a really interesting statement.
Yeah, so this is sort of, again, this idea of what we can do personally and the importance of individual action. And I think if you parse down all of the policy and politics and look at what really needs to happen for us to cope with this crisis and reduce emissions and so on and so forth, we need a fundamental cultural shift in our relationship to energy. Not just how we produce it, but how we use it and how much of it our lifestyles demand. It's a big cultural change. And because of that, individual action then is even more important. Some naysayers will say, well, climate change is so big. What can any one person do? It's futile and so on and so forth. That's wrong. It's not even slightly wrong. It is the opposite of the truth. In fact, the individual actions are more important because it is the sum of individual actions and attitudes that change a culture. And that's what we need to do. We've seen the very same thing in nature. how the response of individual organisms determine the fates of communities, of species, of ecosystems. Same in society as well. We need to make that change personally and then see how that swells to change the policies that will bring these things about. Yes, we need stronger policies, but that will happen as a result of this cultural change. And we're beginning to see some signs of it already. I was on a program not too long ago with a reporter, I think she was from the Washington Post, who really looks at polling data and social attitudes about these sorts of questions. And her point, which I thought was very well thought out, was that the recent spate of extreme weather events, really around the world, but whether it's the heat domes in the Pacific Northwest or the hurricanes in the Southeast or the flooding in the central and northern parts of North America or the wildflowers in the West and so on and so forth, all of these things are beginning to make climate change more immediate, a more immediate threat to people, something they're seeing in their own lives rather than that distant image of the polar bear, on an iceberg, something happening far away. And she thought that connection, if there is any positive result really from these horrible weather events, making that connection is starting to make people worry about climate change personally in a new way, getting towards that question of what we can do and the importance of that cultural shift.
Right. And so it's not just straws and deciding, whether or not you need an electric vehicle or not. It's you mentioned everything we can do.
Yes. Yeah. This question was put to a wonderful biologist named Gordon Orions, who's in his 90s now and still doing interesting work. And his response in term to the question of what should an ordinary citizen be doing, in terms of the climate crisis, his response was everything you can. Mm-hmm. And I thought his choice of the word can was really important because it's such a flexible word. We can do different things in different contexts. That word is very relative, and it helps focus our attention on what we can do on a daily basis. The ways that we shop and drive, cut the grass, the way we vote, the way we protest, the way we hang the laundry to dry, whatever it may be, those are things we can do that can make a difference. Other people in, positions of determining policy or conservation efforts have things they can do. So all of us need to be doing what we can in the context of our own lives to bring about that change.
Mm-hmm. Yeah. And that is just a great way to close. And I know that you're doing everything you can do. I believe this is book number 6 for you, I believe.
Yes.
Yeah, it's fantastic. Well, congratulations again. It's a fantastic read. And Hurricane Lizards and Plastic Squid, there it is. I really enjoyed reading it. I know, Carson, you're doing the same. And thank you both for your time today. It's been a fantastic chat. And hopefully in the future we can have you back again to talk about new things in the climate on your new adventures.
Terrific. Thanks so much for having me on. A pleasure chatting with you.
Thanks so much,
a lot.
Thanks for listening to today's episode of the 2 Degrees C Climate Chat. If you have a question you would like answered, a topic for discussion, or would like to be a guest on the show, please leave a comment below. Sign up for our newsletter by visiting 2degreesc.org and connect to others like you via our social media. We'd love to hear your stories and climate journeys, and if you'd like what you've heard today, please like, subscribe, and comment wherever you hear your podcasts.